Okay, so I've got a ball on a string, and we want to calculate the tension on the string. Now, if I just hang it, the tension on the string would be equal to the weight of the ball, right? Because what's acting on it is the weight of the ball down, and so the tension on the string up. When we spin it over our head, which I'll have to lower myself down here, right? Like you did in the lab, we want to calculate the tension on the string there. So if I want to calculate the tension on the spring, I need to know my angular speed, and I can quick calculate that in my head that it is making 2 revolutions per second, right? So 2 revolutions per second. So I'm like, well, which kind of speed is that? Is that a tangential speed or an angular speed? Well, when it's in terms of something like revolutions per second or radians per second, that's an angle kind of thing. Meters per second, miles per hour is a tangential kind of thing. So this is an angular speed, and that is 2 revolutions per second. Don't go back and double check that was actually the speed. We're going to assume that's right. The only negative there is that's revolutions per second won't cancel very well. Just like there's nothing wrong with feet per second, but we still need to change it to something that will cancel, and what will cancel here is radians. So anytime you want to go from revolutions to radians, you just multiply it by 2 pi. And so that's going to be 4 pi radians per second is my angular speed. The mass of the ball I weighed, and that was 50 grams. And again, nothing wrong with grams, but that's not going to cancel. So in kilograms, that is 0.05 kilograms, right? Because that's 1,000. So you divide that by 1,000. So 0.05 kilograms is 50 grams. And the radius on this thing, I didn't pay attention to where I was holding it. I think it was about here. That's going to be about 40 centimeters or so. Again, I'm trying to keep it short, so we're just estimating a few things. And that is, so 40 centimeters, so 0.4 meters. So now all I have to do is plug in, and that will tell me my centripetal force. That's the force that it needed to keep going in a circle, because without that force, it flies off in a straight line. So that centripetal force is going to be the friction between the tires on a car and going around a curve. Gravity between 2 planets, or a planet and a sun, or whatever. The tension on a string going around in a circle. The tension or the grip that you have to hold on to somebody with if you're like an ice skater who's doing the thing where they spin around and hold on to them, right? So it's the force that keeps something moving in a circle. And that mass we said was 0.05 kilograms. Come on in, Miss Rajwani, you're good. Times 4 pi radians. I'm just making a quick video and I'm almost done. Squared times 0.4 meters. Oh, Mr. Rajwani didn't want to come in. So 0.05 times, now I have to make sure it's the 4 pi that gets squared. So I've got to make sure and use my calculator correctly. So times 3.14 in parentheses squared. So you got to make sure and set it up so that the right thing is squared there. Since it's this part that's squared times 0.4 meters. And that gives us, and if we have all of our units correctly, this is in radians per second, this in meters, this in kilograms, then our unit will be newtons here. So it's 3.1 newtons, right? So if I had my spring scale and I was spinning around with the spring scale, it would say 3.1 newtons. Hopefully that's helpful.